In this video, we're going to talk about how we work with systems of linear inequalities. Systems of linear inequalities. Before we get into actually graphing the systems of linear inequalities, we want to look at our review how we just graph a basic linear inequality. Of course, we were dealing with linear equations, systems of linear equations before. Now we're going to get to inequalities, all right? Ordered pairs are still our solutions. We are going to have systems of linear inequalities in two variables. But since we have inequalities, it means that there's a lot of ordered pairs that are going to be our solutions. And since we graph in our xy plane, in order for us to write or show all of our solutions, we actually have to shade in our xy plane. All right, so let's start with the review. The first thing I do when I graph linear inequalities is I graph the related line, the associated equation of the line that inequality will represent. I'm going to remember to use a solid line for a less than or equal to or greater than or equal to. That means I include the points that are on that line. Okay, the points on the line are included. Or I'm going to use a dash line for a less than or a greater than. That means that the points on the line are not included as part of my solution. All right, I'm going to keep those two things in mind. After I graph the related line noting a solid line or a dashed line, the next thing I'm going to do is I'm going to choose a test point that is not on the line so that I can test in order to determine which side of my line my solutions lie. Will my ordered pairs be on top of the line or the points below the line? To the right of the line or the points that are to the left of the line? So choose a test point that's not on the line, and the important thing here is that that test point is not on the line. And after I test that test point, I'm going to shade my solution area, and I'll be able to show all of my solutions. Let's look at this example here. In this example, I want to graph the inequality y is less than 4x minus 8. All right. Well, since I have a less than sign, I know that when I graph my line, it's going to be a dashed line, right? I don't have an equal to sign, so it's going to be dashed. Now that I know that, I'm going to look at graphing the line y equals 4x minus 8, all right? Of course, you know how to graph this line. It's a linear equation. You can use any method you want, but for our purposes now, I'm going to use the slope and the y-intercept since it's in y equals mx plus b form. The slope is 4, or we can write it as 4 over 1, and our y-intercept is negative 8. And so if I want to graph this line, make sure I'm going to remember to make it dashed. On my y-axis, I'm going to go to negative 8 and plot my point. And my slope is 4 over 1, so I'm going to go up 1, 2, 3, 4, and I'm going to go to the right 1, and I have a point on my line. All right, now I'm not looking at where lines intersect, so the straightness of my line is not that important in this case, but since I'm on this computer and it's a little hard for me to draw, I'm going to go ahead and do my slope one more time. So I'm going to go up 1, 2, 3, 4 to the right 1, and I have a point on my line. All right, just to help me be a little bit more accurate while I'm drawing. All right, and so that's the equation of my line. It's drawn. One thing that I did forget is that it needs to be dashed. So I am going to make sure that I always keep that in mind. It is a dashed line, not a solid line. So I made that mistake. Please don't you make that same mistake. All right, I need to see the dashed. All right, now what I'm going to do since I have the line drawn is I'm going to choose a test point, and that can be any point that's not on that line. All right, the test point that I'm going to use is going to be the point 0, 0. All right, my line does not go through the origin, so I can use that point. All right, so I'm going to put 0 in for x and y into my original inequality and see if I get a true statement or a false statement. This gives me that 0 is less than negative 8. That is false. And so since that is false, instead of shading on the side with 0, 0, my origin, my solution is going to lie on this side over here. It includes all of these points here on this side of my line. Okay, and that's my solution. I know it looks messy, but that's my solution. All right, so all of the ordered pairs that are in this region here will include my solutions. All of these ordered pairs here. I guess this is a better way of shading. Doesn't look as messy. All right, let's look at actually getting to systems of inequalities, right? We're going to use these same methods here, but we want to look at systems of inequalities. If you like to write steps, there are not many new steps you're going to have to write, except for the fact that we're going to have more than one line. So you're going to do that same process that we just went over for both lines, or however many lines you have in your systems. All right, so the first step says to use the same process to graph lines and choose the test points as we would before. But what we're going to do is we're going to wait to the end in order to shade, just so that we can make sure that we don't, overshade and our graph doesn't get too messy. And I'll show you how we can remind ourselves which regions to shade and which regions not to shade. But we're going to wait to the end and shade, and our shaded region, our area, will be the intersection of our test solution regions. Let's look at this example here. All right, well, we have the inequality y is greater than x minus 6. All right, when I see that, I know I'm going to have a dashed line. And what I'm actually going to be graphing is the equation y equals x minus 6. It has a slope of 1, which is 1 over 1, and a y-intercept of negative 6. All right, so if I go to my graph at negative 6, I'm going to have my y-intercept. Now my slope is 1 over 1, so I go up 1 into the right 1, up 1 into the right 1, up 1 into the right 1, so on and so forth. And I'm going to have a dashed line. Okay, and we have also the inequality 2x plus y is less than or equal to negative 1. That's actually going to be a solid line when we graph it. And I'm going to actually solve this for y. To solve that for y, I can subtract 2x from both sides. And I'm going to get y is less than or equal to negative 2x minus 1. Which has a slope of negative 2, or you can say negative 2 over 1. And a y-intercept at negative 1. So here, at negative 1 on my y-axis, I'm going to go down 2 to the right 1. Down 2 to the right 1. Or I can go up 2 into the left 1. And I'm going to actually have a solid line this time. Okay. Now, I'm going to choose test points. And you could have already chosen your test points. You don't have to do it in this exact order, as long as you can graph and find your solution area, your region where all your solutions lie. For this green line, my first inequality, I'm going to choose the test point 0, 0. And I'm going to plug in 0 for x and y into my original inequality. So I'll get 0 is greater than 0 minus 6. And I get 0 is greater than negative 6, which is true. Okay? Instead of shading in that region, I am going to put arrows to let myself know, well, since 0, 0 is on this side of this line, what I would normally do if this was my only line would be to shade in this side of my line here. So I'm going to put arrows there to let me know that I'm shading on that side of my line. Now I'm going to get to using my test point for my blue line, which is the inequality 2x plus y is less than or equal to 1. All right, again, that graph does not go through 0, 0. So I'm going to use 0, 0 as my test point again. And I'm going to put 0 in for x and 0 in for y into that inequality there. That's the equal sign there. So I'll get 2 times 0 plus 0 is less than or equal to negative 1. Well, that's saying 0 is less than or equal to negative 1, which is false. And so instead of shading on the side with 0, 0, I'm going to have to shade on the opposite side, which is to the left. And now that I have my graph, both my lines graphed, and I see my arrows of which regions I need to shade, I am going to go ahead and shade. All right. I don't want to shade in this region here because my arrow on my blue line is not pointing in this region. All right. I want to look at which region all of my lines or both of my arrows point in the same direction, and it is this region here. And so my solution is a little messy. I'm not going to be on that side of that line. It's going to lie in this region here. All right, that's going to be my solution. And so all the points in this region here will satisfy both of these equations, our inequalities. And so that's what my solution would be. All right, let's look at some other examples. In this example, we actually have 3 inequalities. All right, and we're going to do basically the same thing. All right, I'm going to graph each of these individually, use my test points, and then complete my graphing. All right, here I'm going to solve for y, right? I'm going to subtract x from both sides. I get negative 4y is less than negative x plus 8. And then I can divide both sides by a negative 4. Remember, anytime you have an inequality and you divide by a negative, you have to switch your inequality symbol. So it's going to be greater than, and I'm going to have a 1/4 x minus 2. This means that I'm going to have a dashed line. And my slope is going to be 1/4. And my y-intercept is going to be negative 2. So if I go to my graph, y-intercept of negative 2, draw my point, and my slope is 1/4. So I'm going to go up 1 into the right 4. Up 1 into the right 4. And make sure that I make my line dashed. All right. Now I'm going to go to the line x is greater than or equal to 1. Okay. That is going to be a solid line when I draw it. And the line x equals 1 is a vertical line. All right. Any line that is of the form x equals is a vertical line. And it goes through or crosses my x-axis at x equals 1. It is going to be solid. So I'm going to try to draw a vertical line that goes through x equals 1. And that doesn't help me. All right. What I'm going to do so that I won't get confused here is I'm going to go ahead and do test points for these two right here. My test point for my blue line, it doesn't go through the origin, so I'm going to use 0, 0. All right. Had it gone through the origin, I just pick another point. Just as simple as that. All right. So I'm going to put 0, 0 into this inequality here. X minus 4y is less than 8. I'm going to get 0 minus 4 times 0 is less than 8. Well, that tells me that 0 is less than 8, which is true. So what I want to do is I want to shade above this line where 0, 0 is. My test point for x equals 1, I can use 0, 0 as well. Okay, so if I put 0 in for x, I get a false statement. All right, x has to be greater than 1, and if you notice, the numbers, the x values that are greater than 1 are to the right anyway. But since 0, 0 is on the left, I'm going to shade to the right of that line. Last but not least, we're going to go ahead and graph and use our test point for the inequality y is less than or equal to 3. Okay. That is going to be a solid line. And the line y equals 3 is a horizontal line. And it goes through the point on the y-axis when y equals 3. All right, so I know it goes through that point, and it's a horizontal line, and it's solid. So I've got my 3 graphs here. All right, and I'm going to do a test point for this one here. I'm going to use 0, 0. Again, if the graph went through 0, 0, then I would not use 0, 0 as my test point. I would choose another point. But since this graph doesn't go through 0, 0, I'm going to plug in 0 for y here. And I get that 0 is less than or equal to 3, which is true. All right, and you can think about it. The y values that are less than 3 are below, and so I get this region here. And so now I'll need to figure out where all of my regions meet. All right, I have to be to the right of this red line. Right, so I'm definitely not going to shade in any of these regions here. All right, I have to be below the green line and above the blue line, so my shaded region is going to be this region here. All right, and this concludes solving systems of inequalities, linear inequalities.